Now, some Calc 1 courses include the derivatives of the e in the natural log, and some courses do not. It really just depends upon the class. YSU doesn't do it until Calc 2. Kent, Ohio State, they do it in Calc 1. So just to cover all the bases, I want to make sure you know how to do these derivatives. They're just new rules, nothing fancy. You'll like them. The greatest one is the fact that the derivative of an e to the x is e to the x. That's a wonderful rule. The derivative of e to the x is e to the x. So even if it has a function up in the power, so if let's say it has x squared in the power, don't forget, it just stays there, but then you do have to use the chain rule, so you would multiply by the derivative of that function. Okay. So an example of this is if our function was e to the x squared plus 2, the derivative, leave it alone, it stays there, nothing changes, but you do have to multiply by the derivative of the inside stuff, in the powers, the derivative of the power. Okay. The weirdest one is this one. If your base is not an e, and if it's like 2 to the x, so like an example of this one, if our function is 2 to the x, basically due to the change of base formula that we learned last year in pre-calc, it stays there, but you have to multiply by the natural log of that number. And that's due to the change of base between an e and a base 2. And that would fix that issue. So e's are pretty easy to do as far as their derivatives go. Just like we learned that the derivative of a sine is a cosine, the derivative of cosine is negative sine. It's just another rule. So it is your job over the next few weeks to learn that rule. Okay. So before we move on to our natural log, let's take a moment and go to the worksheet about e's. Okay. So once everybody has these rules written down, go to your worksheet about e's. So I'm talking about this one right here. Why was the calculus student confused about y equals e to the x and the derivative of y equals e to the x? So it says for the top part here, problems 1 through 16, you're just finding the derivative and then matching it, and then you're going to fill in the bottom so that you can learn what the answer to the joke is. Okay. So let's just do a few of these. Some of the ones I think are the most weird. So the y, and we'll just start easy to start with. The first one here, this derivative, you just leave the e, but don't forget to multiply by the derivative of the power, because the power isn't just a plain old x. So this one, you would just think of it as a constant times the derivative of e to the x, which is e to the x. So that's just 2 e to the x. It doesn't change. Let's do 9 and 10. So first, remember how we always did some rewrites. Well, this is a good one to do a rewrite for. Let's think about that as 2 times e to the 1/2. I'm sorry, 2, I'm so used to making it 1/2 power. 2 times e to the power of x to the 1/2. That makes more sense. I'm sorry. Okay, so that is a chain rule. Again, remember the 2 is just going to come along for the ride. So you leave everything alone, and e to the x is an e to the x. So in e to the x to the 1/2 is an e to the x to the 1/2. But we have to, since that function is a different thing than just a plain old x, we have to do the derivative. So we're going to multiply by the derivative of that. Well, the derivative of x to the 1/2 is 1/2 x to the negative 1/2. Now, if you look at our lists, they put the square roots back on. So let's talk about how we would make that prettier. Well, the 1/2 and the 2 cancel each other out. That's good. the e to the x to the 1/2 power is just e to the square root of x, which is going to be on top. But that x to the negative 1/2 power is a square root of x in the bottom. So I believe, yeah, that would be m. Okay, so that's it. They did kind of pull that out, but okay. Now I want to do 10 versus 11. E squared is just a number, just a little bit over 6. E squared is just a number. It's like a constant. It's like the number 6-ish. So if you had the function y equals 6x, how would we do the derivative? If you had the function y equals 6x, what's the derivative? 6. So e squared is just a number. So the derivative of this is just e squared, because it's just a constant times x. The derivative is the constant. Don't confuse it. If it has a number up there, it's a number. If it has an x up there, it's a function. See the difference? Because 11, it's got an x up there. So this is a product rule. Put a dot. So it is the first times the derivative of the second plus the second times the derivative of the first. The derivative of an e to the x is an e to the x. One of the greatest derivatives of all time. And then we're going to do 14, and then we're going to go back up and write down our rules about natural logs. Put a little dot, put a little dot. We have to use the product rule for each of these pieces. Okay. So first, let's deal with that. I'm going to make that product, let's make that one red. So it's going to be first times the derivative of the second plus the second times the derivative of the first. The minus comes down. In parentheses, I am going to do the derivative of that. That is a product. First times the derivative of the second plus second times the derivative of the first. Now, they may have made that prettier. There's not much to do. All of those things are not like terms except for these two. This is 2x e to the x's minus 1x e to the x's will be 1x e to the x's. So our final answer would be x squared e to the x plus 1x e to the x plus e to the x. Lots of e to the x's there. Okay, so hopefully that will get you started. 16, that's below it. That's a chain rule. Our stuff is stuck in a squared. Okay. So anyway, that is your, that. This right here, rewrite that as x to the negative 1 and then do a product rule. Okay. Now let's go back up to our rules of the natural log. So please write these rules. You have to have these rules memorized. The main one to remember is that the derivative of a natural log is 1 over x. You could also write that, if you wanted to, as x to the negative 1 power. The derivative of a natural log is x to the negative 1 power, or 1 over x. So these two, it's just because of the change of base formula. It's still 1 over x, but you have to multiply the bottom or divide by the natural log of b. So an example of that, if our function was the log of x, that's a base 10. So the derivative is 1 over x times the natural log of 10. So that's a little example of that in play. If you have a natural log of a function stuck inside, it's just stuff inside, it becomes a chain rule. So it's 1 over the function inside times the derivative of the function inside. So an example of that, let's say our function was the natural log of x squared plus x. So we use the chain rule. What is the original derivative of a natural log? 1 over x. So our derivative is 1 over that stuff. But don't forget to multiply by the derivative of that stuff. So that would be 2x plus 1. And I think it's customary that they would put the 2x plus 1 on top and the x squared plus x on the bottom. Okay. So some new rules that you're going to need to know. The derivative of an e to the x is e to the x. The derivative of a natural log is 1 over x. Just some things to memorize, okay? The derivative of an e to the x is e to the x. The derivative of a natural log is 1 over x. And I've provided 2 examples there. So now let's go, that we have the rules written down. Let's go to the second page of our worksheet. The second page of our worksheet is about the natural log, okay? So once everybody has these rules written down, let's go to the second page of our worksheet, which is about derivatives of logs and natural logs. So the joke you're trying to get an answer to, and what's great about these little joke papers is you can see if you're making a mistake, because if it doesn't spell out a word, you know it's messed up. Okay. So it says, how can 2 lumberjacks chop trees in perfect synchronization? It's going to be something about a log, I would assume. But anyway, let's go and let's do some of these problems. Okay. So let's focus on 1, 2, these little corner here, 1, 2, 5, 6, 9, 10. So we know that the derivative of a natural log is just 1 over x. So if we have a function stuck inside, like number 2, it's going to be 1 over that function times the derivative of that function. What happens to the 3's? They cancel out, which is kind of interesting that it becomes a 1 over x anyway. In the examples I had done for you about the e's, remember if I told you if it was e squared, it's just a number? The natural log of 2 is just a number. The natural log of 2 is a number a little bit below 1. So this is not too far away from 1/2. What's the derivative of 1/2? Yeah, the derivative of a constant or a number is 0. The derivative of this, because that's just a number I could enter into a calculator, is 0. 6 is kind of interesting. The derivative of a natural log that has stuff in it is 1 over the stuff times the derivative of the stuff. Now we're going to discuss what happened in a minute. What happens to the e to the x's? Cancel out. Isn't that just 1? Now let's talk about why it's 1. The natural log of e to the x, since natural log is a base e log, that's just really x. What's the derivative of x? 1. So technically, if you recognize it first off that simplifies to x and then do the derivative, that's okay. If you don't recognize that right off the bat, it'll fix itself for you and show up that it's a 1. Let's do 9 and 10. A constant in front, remember, we don't care. So that would just be 1/2 times the derivative of the natural log, which is 1 over x. You could rewrite that as 1 over 2x. That's okay. 10, put a dot between them. That's a product rule. So it's first times the derivative of the second. Oh, no, it isn't a product rule. Why isn't it a product rule? What's the natural log of e? It's a number, it's 1. So that's just really x again. So the derivative will be 1. Natural log of e is a number. It's 1 because that's e to the first. The natural log and e always cancel out when they're next to each other. Let's do 13 and 14. So rewrite this. Let's do a little rewrite. Let's make that the natural log of x to the 1/2 power. The derivative of a natural log is 1 over the stuff times the derivative of the stuff. Well, the derivative of that is 1/2 x to the negative 1/2. What happens to a negative powered thing? It jumps to the denominator. So that's 1 over 2 times x to the 1/2 times x to the 1/2. How many x's do we have in the bottom? We have 1 total, right? 2 halves. We have 2 halves. So it's 1 over 2 times x. You see that 1 over x appear a lot when we're doing natural logs because it derives from that. So we'll see that a lot. And then let's do 14. And then this is your homework over break. You can do it right now if you have the urge, or you can do it over break. It's due Friday, December 6th. Okay, so let's do the product rule. First, times the derivative of the second plus second times the derivative of the first. What happens to the x and the 1 over x? They cancel, right? If it just becomes a 1. So our answer is 1 plus the natural log of x. So just some new rules for you that this worksheet will provide some practice. There you go. Do your thing.